So now in this video we have a 555 timer. I'm using the NE 555 timer, but whether it's NE or micro A 555, it should work the same. And we have it wired in monostable mode. Once I turn the power on, there we go. And power supply is set to 5 volts, by the way. There it is off to the side. And we have this wired in monostable mode. So the output is going to stay low. That's the stable state right there. Output is low. The blue LED is lit up, but that's not what important. What is important is that the output is low. It's connected to ground, basically, until I press the button. Then the output goes high once I get a good connection, and the output's high, but only for a timed period. Then it goes back low. So the output being high, red LED being on, is not stable, as you can see there. It goes back to blue. It wants to stay blue. So that's its one stable state. So we'll zoom in and take a closer look. So first off, if pin 4 sees close to 0 volts, the output's going to stay low no matter what. So we disable it. We give it the farthest other voltage we could give it to the positive supply right there. That disables it, prevents it from doing anything. We have to power the integrated circuit as well. Pin 1 to ground, pin 8 to the positive supply. Now, when it comes to the output was low. We saw the blue LED was lit up. That's because the current flows this way, right there. Blue LEDs are naturally brighter than red LEDs, so we got a much higher value resistor. 1000 ohms versus 220 for the red LED for a couple of reasons. One is because red LED is not as bright, and then when the output is high, you don't actually get 5 volts out. You know, you do get 0 volts pretty well, but you lose some of that positive supply voltage due to the transistor. So it's actually only about 3.5, in that range, you know, maybe closer to 4. But you do lose a little voltage. So, in any case, let's get back to the timing. We started low. When we were low, the capacitor was discharged. 7 connects to ground. 7 is like a switch though. Pin 3 can either source current or sink current. Pin 7 only sinks current. Then it's an off switch. It doesn't do anything when it is off. So when the output's low, it's discharging any current through that resistor. It just goes to ground right there. So capacitor stays completely discharged. Now we got pin 2. Pin 2 is the way to set the output high. It doesn't do anything while it has more than a third of the supply voltage right there. So 5 volts is held there. But we use a pull-up resistor. You close the switch, current's going to trickle through that resistor, then go right to ground. So this does not see any of that 5 volts anymore. Just has a direct connection to ground when you close the switch. That's all it sees is 0 volts. That's less than 1/3 of the supply voltage. That sets the output high. At the same time, it turns off the switch. That's the important part here. So no more current is flowing through there. Like that doesn't exist. No current flows in or out of the inputs either. But in case, it was being held to, now it's getting the current going through the resistor because that switch is off, and that's charging the capacitor. Once pin 6 sees 2/3 of the supply voltage, so their values matter. Higher values will take longer, lower values will be quicker. I think you might want to limit to 100 microfarad though for the largest value for the capacitor, because sometimes you're shorted to ground. So charges 2/3 of the supply voltage. Pin 6 says set the output low, and set 7 to the discharge pin to ground as well. Then the capacitor instantly discharges. So that's when it's low. Again, we have that capacitor constantly discharging, so it's not doing anything, and pin 2 is waiting for that low input, so it's not doing anything. We just stay in that state where it is low until we press the switch right there, which sets it high, but also starts the charging of the capacitor. Once it gets to 2/3 supply voltage, then it goes back down to low and stays in that state again until we press the button. Hopefully that makes sense. So for those of you not used to building circuits on the schematic, I'll show you how I did this one. So 100 microfarad capacitor there, and there's the resistor that it's either charging the capacitor or it's draining the ground, depending on what the situation is. And so that's one reason why you want to use, you know, relatively high value there. Otherwise you're losing a lot of current. And so you can adjust their values as needed for the timing that you want. I set this for about a second right there where it's low. So there's our output 3. Again, right now it's connected to ground pretty good. And I can also hold the button. As long as I hold the button, this is more powerful pin 2 than pin 6 there. So it's going to stay high right now. So we have as close to the positive supply as we can get right there. So if you set it, if you just hold the button, it's going to stay high as long as you hold the button, but as long as you pass that timing period, as soon as you release it, then it will go low like that. And of course, you don't need to use LEDs. You don't need to use the high and low. Maybe you don't care when it's low. You have nothing connected to it. You just want something to happen when the output is high. Right there, you could do that. Or vice versa. Maybe you want to just turn something off after a period of time. Then you would have it syncing current, all the time until you set the timing right there. So the switch doesn't seem to be working as good as it normally does. They don't fit into the breadboard perfectly right there. It can easily pop out even if I move it. And it's worse when you first put it in there. So some people modify it by filing it down and stuff so that it fits better in the board. But I just keep putting it in until the board gets used to it over time. These higher quality boards, they kind of maintain their integrity a while, so it takes a little longer for them to get a little bent out of shape to accept them. So just thought I would mention that for those of you new to these switches. They will literally fly out sometimes when they're first inserted into a board. The board will really reject them. So that's it for this video. Thanks for watching. Make sure you check out one of the other videos I posted on the screen and check out the links down below. They all help out a lot. I'll see you in the next video.